Okay, in the previous video, we have seen some basic concepts about alkalinity, that is, how the alkalinity is caused. So, basically, there are three main ions: hydroxyl ions, carbonate ions, and bicarbonate ion. Depending on the value of pH of water, the alkalinity varies. Okay, if pH is more, that is more than 10.2, then the alkalinity is caused only due to hydroxyl ions. If it is less than 10.2, then it is due to carbonate and bicarbonate ions. So then after we have seen estimation of total alkalinity, two cases: when pH is greater than 10.2 and when pH is less than 10.2, and some causes of alkalinity. Now we will see how to measure alkalinity, that is measurement of alkalinity. So about acidity, if you remember, the acidity was measured due to with the help of process which is called as titrometry. Similarly, this alkalinity is also measured with the help of titrometry, or we call it as titration. It is expressed in terms of mg per liter of CaCO3. Okay, alkalinity is also expressed in terms of mg per liter of CaCO3. Now we'll see once again, as we have seen alkalinity. So this is the basic of titration. Okay, basic setup for titration. So it consists of a conical flask and a burette. A titrant is present in this burette, and the sample, that is water sample, is present in the conical flask. So initially we put water sample in a conical flask, let's say 25 ml. Then we will add some indicator to the water sample. 2 to 3 drops of indicator we will add. After putting the indicator, there will be some color that will come to the water sample. Let's say if we use methyl orange in case of acidity, then the color will first appear as pink. Then slowly we will drop by drop this titrant into the water sample. Up to which point we have to drop? Up to the point when the color of the water sample changes from pink to yellow. Now in the same way, for this acidity also same process we have to follow. Now we will only write what are the titrant used in this. So that is the liquid which is present in the burette. So in this case it is H2SO4 and it is diluted. Okay, and what is the indicator used in this case? So in this case there are two indicators. The first one is methyl orange, and the second one is phenolphthalein. See, for all the titration, these indicators and titrant does not remain same. It is same. These indicators are same only for the alkalinity only. What was the titrant used in in acidity? The titrant used was NaOH. If you remember, titrant was NaOH. In this case, the titrant is diluted H2SO4. Now we will write what about the color change. So if we use the methyl orange, then the color change will be from yellow to pink. And in case of phenolphthalein, the color change will be from pink to colorless. So you have to keep doing the titration till the pink color becomes the colorless. Now when we will use the methyl orange, then as soon as the color changes from yellow to pink, we will take the reading, and that reading will be called as M alkalinity. Okay, M alkalinity, or we can call it as T alkalinity. And as soon as the color changes from pink to colorless, we will take the reading, and this we will call it as P alkalinity. Okay, see, the P stands for phenolphthalein alkalinity, and this M stands for methyl orange alkalinity. So this M alkalinity or T alkalinity is same only. Now based on this P value and T value, we can estimate the concentration of hydroxide ions, carbonate ions and bicarbonate ions. So the next heading will be estimation of OH minus, CO3 minus 2 concentration and HCO3 minus concentration. See, if you look on this video, that is previous video, you can see that there is this term. This stands for concentration of carbonate ion. From where you will get this value? You will get this value from the table now, which we are going to discuss here. And that table's value, if you see, so first I will write it down, then we'll discuss. So the first thing is relation between P and T. So the first is when P is equal to 0, then second, P is less than half of T, then P is equal to half of T, P is greater than half of T, and P is equal to T. Now what is P and T? P is the phenolphthalein alkalinity and T is the methyl orange alkalinity. So the next table is here for OH minus concentration. This is for carbonate concentration and this is for bicarbonate concentration. So when P is equal to 0, OH minus concentration is 0, CO3 minus, okay, it is minus 2, this is 0, and bicarbonate is T. Similarly, the other values are 0, 2P, T minus 2P, then 0, 2P, 0, then it is 2P minus T, 2T minus 2P, 0, and last is T, 0 and 0. So this is the table for estimation of hydroxyl ions, bicarbonate ions and carbonate ions. So first what we will do, we'll carry out the titration process. We'll find out the value of P, we'll find out the value of T. Then by looking at these values, we will see which of the relation we are getting. Let's say P value is 100 and T value is also 100. Okay, P is 100, T is 100. So which of the following relation we have to use? The last one, P is equal to T. P is equal to T. So when P is equal to T, what is the concentration of OH minus? It is equal to T. And what is T value? T value is 100. What is the concentration of carbonate? It is 0. What is the concentration of bicarbonate? It is also 0. So with this table you can find out this concentration, and once you get the concentration, then you can use the formulas that we have discussed in estimation of total alkalinity. Now how to remember this table? So you have to learn this table, but there are few points that you can remember, that whatever the sum is there, that is sum in a row, that is equal to T. So see, in the first case 0 plus 0 plus T, that means sum is T. In the second case also 0 plus 2P, T minus 2P, minus 2P plus 2P cancel, sum is T. So this third case is an exception. You remember this, when P is equal to half of T, then it is 2P. If you remember this, P is less than half of T, that is T minus 2P. Opposite of this is present in this, P is greater than half of T. So T minus 2P, 2P minus T. If you get 2P minus T, then you know the sum is T. So you can just subtract t minus 2p minus t, you will get 2t minus 2p. Similarly, the last is also t. So sum is equal to t and this initial is 2p. With the help of these few points, you can remember the table. Okay, this is an important table. Many times questions are asked from this directly. That is, they have given the value of p and t. You have to calculate what is the value of OH minus or what is the value of HCO3 minus. So they can ask any question from here. Okay, so this is all about the measurement of alkalinity. So one more thing we will write in here, that is one conversion formula. So you write it down. So concentration of X in mg per liter. Concentration of X in mg per liter, that is, this stands for concentration of X and this is in mg per liter. This is equal to concentration of X in moles per liter. Concentration of X in moles per liter. So that is concentration of X in moles per liter multiplied by molecular weight into 1000. Okay, so this is the formula for conversion of moles per liter into mg per liter. See, in question sometimes the concentration is given in this moles per liter. So if you want to convert this, you have to multiply the concentration in moles per liter into molecular weight into the 1000 value. So this is the conversion from moles per liter to mg per liter. Now sometimes in question equivalent per liter is given, that is equivalent moles per liter. So for such case, conversion will be concentration of X in mg per liter. This is equal to concentration of X in equivalent per liter or we can say this milli equivalent per liter, moles equivalent per liter into, here we have to take the equivalent weight. This is equivalent weight multiplied by 1000. So if you look carefully, then the only thing that is changing here, if equivalent weight is given, then we have to multiply by equivalent weight in terms instead of molecular weight. Now what is the formula for equivalent weight? So we have already written that equivalent weight is equal to molecular weight divided by valency. Molecular weight divided by valency. So this is to be used when moles equivalent per liter is given in question and you have to convert it into mg per liter. See, all the concentrations we are dealing in mg per liter only, so convert everything into this mg per liter. So if you take one example here, example of calcium carbonate. So what is the molecular weight of calcium carbonate? So it is calcium plus carbon plus oxygen into 3. Okay, so calcium is 40, carbon is 12, and oxygen is 16 into 3. So this is equal to 100. This is molecular weight. And what about equivalent weight? Equivalent weight is equal to molecular weight divided by valency. Molecular weight is 100. What is the valency of calcium carbonate? For this you have to dissociate it. That is Ca plus 2 plus CO3 minus 2. So this 2 is called as valency. So this is 2. So molecular weight of calcium carbonate is 50. Molecular weight of calcium carbonate is 100 and equivalent weight of calcium carbonate is 50.